today we get to start talking about my second favorite F word.
Fraction.
Factoring.
Fraction is your first favorite.
Fractions is my first favorite, remember?
Oh, yes.
Yeah. Factoring, okay? Now here's the thing about factoring. There's lots of different polynomials that we're going to have to factor. Lots of different sizes of polynomials that we're going to have to factor. So we're going to kind of chunk them into groups and worry about today specifically binomials, how you factor binomials when you see them, things like that. Okay, we're also going to worry about today looking at factoring polynomials with 4 terms. Okay, now I know that seems weird that we're going with 2 terms and 4 terms, but those are the easiest kind. But the best part about it is if you got 4 terms, you got 3 terms in the back. Okay, so we're doing 2 terms and then 4 terms. You just got to trust me for a couple days that I know what I'm doing. I've done it a couple times before. Okay, so the other thing about factoring is that if you take pre-cal next year, you're going to see it. If you take college algebra next year, you're going to see it. If you take calculus the year after that, you're going to see it. Okay, it's kind of a big deal. But also, even just besides that, in a couple weeks we're going to do factoring again. And then in a couple more weeks we're going to do factoring again. Not really specifically factoring. Like, it's not going to say, let's factor this polynomial. It's going to say, we need to solve this equation, but the way we're going to solve it is by factoring. We're going to get to different subjects or different topics in the TEKS that we have to go through, and the way you figure those things out is by factoring. Okay? We're going to use it probably 3 or 4 more times this school year. So let's get it really good now so that we have a firm basis for the next couple times that we use it here in Algebra 2. And then depending on what math class you take, you're going to have it in either one. So that is a firm basis also. Does that make sense? Okay? So like I said, today we're going to start with binomials and trinomials. Before we do that, though, we need to talk about greatest common factor. Okay? Now, sometimes the words greatest common factor can be deceiving because people think it has to be like a real big number or bigger than everything else that's there, right? It's just the greatest common factor, which means it's going to be at least as small as the smallest term that you can factor out of each term, right? So for example, if I say here is a polynomial, in this case just a binomial, 2x minus 10, what is the greatest common factor of each of these 2 terms? Yeah, what are they both divisible by, right? A 2. If I factor out a 2, what do I have left from the first term? An x. And what do I have left in the second term? A minus 5, right? Now, we're just starting off little, so keep that in mind, okay? What if the problem looked like 3x squared minus 4x? What's the greatest common factor in this problem? X, right? Do you see how they're both of it? Why didn't you say x squared? Because the first term has an x squared.
You
can't factor out of the second one, can you? Okay, so that's a good one. So x, what's left if I factor out an x from the first term? 3x. And what's left if I factor an x out of the second term?
4.
Minus 4, perfect. 2x to the 5th plus 14x to the 3rd. 2x to the 3rd, that's perfect. Okay? 2, because for the constants between 2 and 14, 2 is the greatest common factor. Do you understand why people might say that it's 14? Because of the word greatest, right? People see that and they think it has to be a big number, like I said a minute ago, okay? But if it's the greatest common factor, it's the biggest number that they will both divide by, right? The biggest number that these will both divide by is 2. I can't choose 14. 14 doesn't divide into 2, does it? Okay? So if I take out a 2 out of the constants, what about the x terms? What's the biggest x term that they're both divisible by? X to the 3rd. Very good. What's left if I divide the first term by 2x to the 3rd? Very good. X squared. Now, how did you do that?
You have to subtract them because you're dividing.
We're dividing exponent, or we're dividing bases, so we subtract the exponent. Okay? 5 minus 3 is 2. Remember that? Now, I know it's been a while since you talked about exponents in Algebra 1. It really has. Okay? So, try to be patient with you guys about that. That's easy. I mean, being patient. Well, but that's not always true. I'm going to be patient with you about that for now. Okay? It's just weird because we will actually get to exponents, but not until a couple units from now. Except we have to do them now. But, whatever. Okay. So, we have x squared left when I divide the first term by 2x to the third, right? What do if I divide the second term by 2x to the third? What do I have left? 7. X to the third divided by x to the third is just 1. And then 14 divided by 2 is 7. Okay? So, sometimes you're going to be asked to factor a problem, and before you can do any of the things that I'm showing you today, any of the patterns and practices that I show you today, you're going to have to factor out a greatest common factor before you can even start, because it's not going to seem to fit until you take out a greatest common factor. Does that make sense? Okay? Now, I'm going to teach you a couple patterns today. Okay? Now, sometimes people call them formulas. Well, if I ask you to memorize 5 formulas, your first reaction is, I don't want to do that. But what if you just remember patterns? Isn't that easier?
Yeah.
It is, isn't it? Okay, so let's just remember some patterns. Okay? The first pattern I want you to remember is called the difference of squares. The difference of squares. Well, what does that mean? What's difference mean? Subtraction, right? Subtraction. And what is a squared number? An exponent of 2. Okay, I get that. But do all squared numbers have an exponent of 2?
No.
Can you give me an example of a squared number that doesn't have an exponent of 2? 64.
64.
Right?
It's like 60.
60? Oh, 16. Yes, that's exactly right. Do you see what types of numbers I'm talking about? Squared numbers? Okay? So if I have the difference of squares, our general pattern is going to look like this. A squared minus B squared. Is that the difference of squares? Now here specifically for the pattern, we do have squared numbers, right? A number with an exponent of 2. Okay? When we factor the difference of squares, we're going to end up with 2 binomials. Do you? Good. What goes in the beginning of each of these binomials? A. It's the square root of the first term. What goes at the end of each binomial?
B.
Perfect. Tell me about the signs.
Plus minus.
Perfect. Wait, should this one be the minus one and this one be the plus one?
It doesn't matter.
Oh, it doesn't matter. Why? Why doesn't it matter?
Because it still has the same answer.
Still has the same answer? So basically it doesn't matter what order we multiply in? So if I have a plus b times a minus b, that's going to be the same thing as a minus b times a plus b? Yeah. Does that make sense? Okay. So let's do some examples of these. Okay. X squared minus 64. That's a number you mentioned earlier, so I'll go ahead and use it. First of all, I need you to recognize that that is the difference of squares. Do you recognize that?
Yes.
So you notice that it was a minus. Why is it making that sound? Stop it. You notice that it was a minus. And then you notice the first term is x squared. Well, that's clearly a squared term because you actually say the word squared. And then 64, you know that's a squared number because what times itself is 64? 8, right? So I'm going to end up with 2 binomials. The first one is going to be, you can't say it after I write it. I want you to say it before I write it.
Sorry. Plus.
X plus 8 and
Yes.
X minus 8. Perfect.
Boom.
Boom is right.
Bow. Hello.
Are they all that easy?
No.
Okay, let's get a little bit more.
Bow.
Is that the difference of squares?
Yes.
Are you positive?
I'm 100%.
Good job. two binomials then.
I think I did.
What are my binomials?
2x plus 7, 2x minus 7.
2x minus 7, 2x plus 7?
Yes.
That's not what you said, is it?
It's not.
I just wrote it backwards.
Well, it doesn't matter.
Is it, oh, it doesn't matter. Okay, good job. So I did that on purpose?
Yes.
Okay, good. I'm glad you recognized that.
Actually,
Because the first one we did, we wrote plus first and then minus. I just wanted you to make sure to realize it doesn't matter what order the signs are in. As long as they are
Plus minus.
plus minus. As long as they're opposites, right? They can't be both plus, and they can't be both minus, can they? Good job. Okay, one more. 25x to the 4th minus 1. Is that the difference of squares?
yes.
Wait, there's not a squared in the first term.
1 times 1 squared is 1.
That's the second term.
The first term is that like that.
Oh.
You have to
Right.
factor something else.
It says x to the 4th. It doesn't say x squared.
You have to find a great common factor.
You have
Wait, it is a squared term?
It
X to the
is.
4th is a squared term?
x squared squared.
Oh, x squared squared. Okay, so
X
two
squared
binomials.
squared.
Yeah, right. X squared times x squared is x to the 4th, right? So isn't that still a squared term?
Yes.
Okay, good. So what are the two terms, or what are my two binomials?
5x squared plus 1.
5x squared plus 1, 5x squared minus 1. Very good. On a scale from 1 being really easy to 9 being hard, where would this fall? Negative 1. Okay, no, I made it clear it goes from 1 to 9. 4? Okay. 3? All right, so the next one is going to be a 1. Okay? The next one's called the sum of squares. Sum of squares.
It's just some
What's the pattern look like?
Squares of
X
squares.
squared.
A squared plus b squared, right? So when you recognize a problem like a squared plus b squared, for example, x squared plus 64, do you recognize that as the sum of squares? Is it adding?
Yes.
Are these both square terms?
Yes.
Okay, you're done.
We're
So
done.
it's just
Yeah, you
that?
can't factor it. It's prime. So as long as you recognize it as the sum of squares, you're done.
Oh.
See why I said it was a 1?
That's a one.
So we write prime under it?
Prime. Yep, that's prime.
Alright.
What does the word prime mean? Its only factors are 1 in itself.
I think so.
Okay? Questions so far? Doing okay? All right.
Difference
Oh, I was writing it right. Sorry. Cubes. So tell me what that's going to look like.
A cubed minus 3.
A
Or B
cubed minus
minus
b cubed. Very good. Now, if I just straight wrote out the pattern for you right here, it would look confusing. So I am going to give you the pattern, but I'm going to walk you through the pattern so that you'll understand it's really not confusing at all. Okay? When you factor the difference of cubes, you're going to get a binomial and a trinomial. If you can get the binomial, the trinomial is cinchy.
Is what?
Easy. Okay? So if a cubed minus b cubed is the problem, that's the difference of squares, this is what the binomial looks like. How do I get from a cubed to a?
Because it's the cube, so it's
Cube root, right? I take the cube root of it. Okay? Now, please understand I'm leaving off the signs on purpose for now. I'm going to go back in and put those in just a second. Okay? If you know the binomial, the trinomial is easy. Okay? Here's how you get the trinomial. Take the first term in the binomial and square it. A squared. To get the second term in the trinomial, multiply these two together. AB. To get the third number in the trinomial, b squared. Square the second term of the binomial. That seems pretty easy, right? But if I would have put that up there, it would have looked confusing, right? So it's too easy. Oh, okay, that's fine. I don't mind stuff like that. That's okay. Okay? Binomial and trinomial. You got it? Now, here's the signs. Okay? Here's the signs. Whatever the sign was in the problem, that's the sign of the binomial. Okay? Whatever sign is opposite of that comes next. And the last one is always plus.
Last one is always plus?
Always.
And the first one and that one is the opposite.
Opposites.
Nice.
Okay? But whatever sign was in the problem is the sign that comes first. Whatever sign is opposite of that comes next. And the last one's always plus. Now, let me show you some good news before I show you any examples. Is that okay? You want some good news?
Yes.
We need to talk about the, sum of cubes. It would look like a cubed plus b cubed, right? Guess what the pattern looks like? A binomial and a trinomial. Guess what the binomial looks like? A and b. Guess what the trinomial looks like? A squared, ab, and b squared. And guess what the signs are? Whatever was
Plus,
here,
minus,
whatever is in the problem is in the binomial. The second one is
minus.
opposite of that, and the last one is always plus. So if you know one of these, then you know the other one, don't you? Okay? Now, the major difference between squares and cubes is the fact that you can factor both difference and sum of cubes, right? Can you factor both difference and sum of squares? No, right? But now that I've walked you through it this way, is this hard, you think? No. So let me give you some examples. I'll give you the easiest example I could possibly give you for the first one. I'll give you a harder one. It's not the hardest. I don't want to spoil it. Here's the problem, okay? Well, what does my binomial look like if that's the problem? What's the cube root of x cubed? X. What's the cube root of 1? 1. Now that I have my binomial, let's fill in the trinomial. Square the first term, x squared. Multiply the first times the second, x. Square the second term, 1. What are the signs?
Minus, plus, plus.
Minus, plus, plus. Now, I need you to understand why I do the signs second instead of at the same time. A lot of this just has to do with how my brain processes this, to be fair. Okay? So if you can handle doing the signs at the same time, you go right ahead. But here's what happens if I don't say that. If I say first times the second for the middle term over here, people are going to say negative x, aren't they? Okay? That's why I do the signs last. Because right now I just want you to concentrate on the terms, and then you can concentrate on the signs. Okay? Now, the thing about these is that you should never get them wrong, because you can always check them. All these ones that I just did for you, the difference in sum of squares, you can check them. Because what if we took the answer right here? By factoring it, I'm kind of dividing it out, aren't I? I mean, we have dividing polynomials. We did long division and synthetic division, but isn't factoring a type of division also? So if I want to check to see if it's the right answer, couldn't I multiply this out? I would get x squared minus 8x and plus 8x, which would be 0, right? And then minus 64. Did I just end up with x squared minus 64? Yeah. Now this one's obviously a little bit more involved, because there's 3 terms over here, so I'd have to distribute. But in the end, I'm still going to get x cubed minus 4. And that's why the signs are how they are and where they are, because that's what it takes to cancel out all those middle terms that you would get. Does that make sense? Okay, so let's do another one. (27x cubed plus 125). Binomial, trinomial. What goes in the binomial? What's the cube root of the first term? 3x. Because 3 times 3 times 3 is 27, right? Okay. What goes in the second term of the binomial? What times what times what equals 125?
5.
It's just 5. Okay. Now, I had this up earlier. I don't know if you had time to look at it or see it. This is a chart I made for an earlier class. Did you see this a minute ago?
Yes.
Okay. Now, do I expect you immediately to look at 343 and know that that's the cube root of 7?
No.
Or 7 cubed? No. But I want you to recognize that, ooh, that's something. I know that's something. So when you see 125, you know that's something. That's what I would like you to be able to do. Okay? I'd like you to recognize these numbers as either squareds or cubes, and you may not know what they are off the top of your head, but you recognize them as either a squared or a cube and can go figure it out from there. Does that make sense? Okay. Back to the trinomial. What's the first term in the trinomial? This is where people mess up a lot, just for the record. 9x squared, right?
Yes.
It's not 3x squared and it's not 6x squared, is it?
No.
We're saying 3 times 3 and that's 9, and x times x and that's x squared. Does that make sense? Okay, what's the middle term? 15x, very good. And what's the last term? 25. And what are the signs of this answer?
Plus, minus, plus.
Plus, minus, plus. Very good. Any questions so far?
No.
So if I give you the difference of squares, the sum of squares, the difference of cubes, the sum of cubes, could you do those problems?
Yes.
Awesome. Now the last type I want to talk about today is factoring by grouping. Okay? And when we factor by grouping, we're going to factor by grouping when there are 4 terms. But the cool part is we already talked about greatest common factor, and so we're going to use that knowledge right now, okay? Because this might look difficult, but that does not, does it? And that's the neat part about grouping, is that we only do 2 at a time. We group the terms. Excuse me. You're fine. Okay? So let's just look at the first 2 terms. What's the greatest common factor in the first 2 terms?
3x.
3x. There's a 3 and a 6, so the greatest number that both of them, the greatest number that divides into both of these is 3, right? And the
x squared.
X squared, yes, absolutely. 3x squared, thank you. Okay? The greatest x term that divides into both of these is basically going to be the smallest exponent, isn't it?
Yes.
Okay? So if I factor out a 3x squared, what's left from this term? X. If I factor out a 3x squared from this term, what's left?
2.
Plus 2. Once that I have that, I ignore that for a second. And I just look at the second 2 terms, the last 2 terms. What do these 2 terms have in common?
5.
5. So if I factor out a 5, what's left?
X plus 2.
Now, do you see the magic thing that just happened?
Yes.
No, don't they both have an x plus 2? Here's what I mean. This is 1 term. This is 1 term. Okay? Is there a common factor in these 2 terms? X plus 2. if I factor out an x plus 2 from the first term, what's left? 3x squared. If I factor out an x plus 2 from the second term, what's left?
A 5.
We already did that one. So we factor out an x plus 2, and what's left is a 5. And then we're done. And then we're always done? Or just on this problem?
That's on the problem.
Just on this problem. Can I show you one that is when we're not always done when we get there? Okay. You guess? Okay. You have time? You have time for me to show you one more example?
I don't know.
Do we have time?
Yes.
I don't know. Those are weird.
X cubed plus x squared minus x minus 1. Okay? You ready? Just look at the first two terms. What's the greatest common factor? Squared. What's left when I divide it on x squared? And?
0.
What's something divided by itself?
1.
1. Okay? Now let's ignore that part. The thing is, I have to divide something out.
-1.
Okay, even if it's just a positive one, I have to factor something out. I can just not factor anything out. Does that make sense? Okay, now, I'm glad that you guys recognize that this is, I want to factor out a negative one. Because if I just factored out a positive one, the parentheses would say negative x minus 1, right? And what has to be true about these two parentheses?
They've got to be equal.
They have to be the same, don't they? Because if they're not the same, I can't factor them out of each term, can I? Okay, so I'm glad you recognize that it's a negative 1. In fact, if I factor out a negative 1 from each of these terms, what do I have left? X plus 1. So that's good because now I have this and this, right? So x plus 1 is the common factor from each of these two terms, right?
Yes.
So if I factor out an x plus 1 from the first term, what's left?
X squared minus 1.
Okay, well, we'll go with both of them. That's fine. X squared minus 1. But just for the record, if I factor out an x squared from the first term, I just get x, excuse me, if I factor out an x plus 1 from the first term, I just get x squared, right? And if I factor out an x plus 1 from the second term, I get minus 1. So that's how I got to there, right? Am I finished this time?
No.
Why?
Because you can factor more.
Why?
Because there's
X squared minus 1 is the difference of squares, isn't it? Okay? So I keep this x plus 1 because that was already part of the answer, right? How do I factor x squared minus 1?
And negative 1.
Two binomials, right? And what are my two binomials?
x minus 1, x plus 1.
X minus 1, x plus 1.
Is that your answer?
Yeah.
Whoa.
Now, I do want to be clear about something. You might see the answer written like this. Why?
Because it's x.
There's two x plus 1s, right? So I could combine those together and write them as squared and then have the x minus 1 right there. Okay, is one of those more correct?
No.
Not really, no. Okay. Any questions about factoring by grouping? Yes, ma'am.
Okay, so when it says the x, do you always have to put the common factor first?
No,
And then
no.
the-
This is another situation where order doesn't matter.
Okay.
The order of the multiplication doesn't matter. So I could have written x squared minus 1 and then x plus 1. That's fine. Typically, I've written it this way because this is what we're factoring out. And up here, whatever I'm factoring out, I write first. Okay, but that does not matter what order I'm multiplying in, so it doesn't matter which one I write first. That's a good question. Okay. Any more questions?
No, no.
So, could you factor difference and sum of cubes?
Yes.
Could you factor the difference in sum of squares?
Yes.
Can you factor out a greatest common factor?
Yes.
And can you factor by grouping?
Yes.
All right.